I guess I'm live, sort of, maybe, possibly. We'll have to wait and see. It looks like it's happening. Okay. Same old routine. Gotta do a couple of things, so you have to just wait until I finish those things before I can start pretending, yes, to whatever, figure out how to. Um, that isn't right. Okay, I don't know exactly why that isn't right, but whatever. It's always something. Close enough. So I think that's close enough. So to the drawing board. So we don't need this, and we will start there. Well, that might work if I do this. Yeah, I don't know if I like that. Yeah, it's kind of encroaching on me. I wish I could just get rid of this stupid whatever welcome crap. Anyway, I'm not really a welcome kind of person. Uh, all right. So mindless marbles video. Um, thought provoking, you know. If you explain it better than he explained it, okay. And so this is pretty similar to the point I've been making about why it's all right. mgT and not mgh. So whatever. mgh is what they use, basically to say mv squared. And that's the verses here. So I point out how you can just lift two one objects, you know, 1 unit of distance, and get the same weight on a scale, okay, that you get from a object dropped 4 units of distance. So 4x equals 2x, and that doesn't make any sense. So that's what mgh does. And mgT solves it because the time, okay, factor, basically says it's the same thing. It's not 4x the distance, it's 2x the time, which is the more important part. It has to be 2x the time, so 2 equals 2. So mgT wins. Now, in this mindless marble scenario, you could describe it as just going down a staircase. Okay. And say if you just dropped an object 1 unit of distance at a time, then you'd have 1 unit of time and 1 unit of distance, 1 unit of distance, okay, per step, right? Alright, so I pointed that out. And of course, this would be more energy because it's more time in the gravity. Alright, and so you could go 4 units of time, 4 units of distance, 4 units, and then you could theoretically launch the object to back to that same height. Notice I am drawing an arrow that can't go straight up and accomplish this task. That's part of the problem. But anyway, this would only be 2 units of time, and theoretically 2 units of distance, 2 units of gravity you're having to overcome. So somehow you'd be able to just take 2 units and create your perpetual motion. Now again, mgT works. It explains why this is, because this is 4, okay, times the time. Then this is only 2 units of time, 2 and 4. So it does explain why. Now the question is why doesn't this work? I mean, why can't we make perpetual energy machines? Just taking advantage of the fact that if you drop something in gravity slowly, it is more energy. Well, it sort of goes back to Galileo again, and the fact that he dropped things on slopes. All right, and as I explained yesterday, so I do explain this stuff over and over again. But anyway, you end up with a velocity, okay, that's going to be the same as the velocity you gain from dropping it straight down here. So these velocities will be equal, And you obviously do have a difference in the sense that not only do you have the same velocity, you drop it straight down versus rolling it down the slope, you also, in this case, end up with angular momentum. So you also have an object, say if I had two objects in space, one that was just going this way, okay, and one that was spinning as it went this way. So it was going that way the same speed, but it was also rotating. You'd have to say, well, the rotating object has more energy. So somehow whatever created these two, if I end up with rotation after it's done, well, that is more energy. Now the question is whether the rotation comes out of the velocity, and that one I'm not sure of, frankly. I haven't seen the experiment. I mean, maybe your velocity here is a little bit lower to account for your angular rotation. But the point being is that the total time this takes is a lot longer. Okay, this is a greater than, big greater than, and this is less time to fall straight down. So falling straight down take you 1 second. Rolling could take you 10 seconds, depending on how much of a slope I create. So you're in the gravity a lot longer. But what are you doing? You're heating this surface, right? So there's clearly more energy in taking longer to allow it to fall. So whatever, if this is a paradox, it exists, back in Newton's day, because clearly by just mgH standards, all right, and if I don't account for the fact that I'm allowing it to fall much slower, the fact is that the total energy, if I could collect this heat that I created in this the falling process, well, then I'd say I have I have this falling energy plus this extra heat energy, which would mean I should have the energy, enough energy to lift the object back up again, because I should be able to convert this heat into lifting energy to get it right back to where it started and create the perpetual motion, or the energy plus system, the free energy. But no one's ever done that. So apparently it's not that simple, and it has something probably to do with, if you think of this in spatial geometry, you're banging into something else and converting your energy into its energy, and it's going to take the energy too, so you never can keep the energy in the place you want it to be able to launch something. Alright, so a way I thought to defeat this, this one, that is, where you clearly have 4 times, okay, you're hitting something. So essentially you could say if each time this thing fell it was 5 pounds, 5 pounds, 5 pounds, 5 pounds, and when it fell directly it was 20 pounds. Okay, is that the way it turns out, or no? 10 pounds. Okay, yeah, double. Alright, so you're doubling its weight by dropping it 4 times from 4 times the height, and each one of these units is a 5. So you're saying, okay, I should be able to make 10 out of 4 5s, right? 4 5s, which is a lot more than a 10. I should certainly be able to lift this back up again, because it takes the same energy, the same pressure that it lands with is the same pressure I can launch it with, okay, theoretically. But we know that all of these systems have some losses in them, so I can't just make the little rampy thing. I can't just drop a ball on this side and have it go right back to where it started and right back again. No, smiley face. And stay that way. It loses a little bit of energy each time, and so I can't maintain that system either. All right, so for this thing, I was, you say, gee, that's 4 times the energy. That's it's twice the time, 4 times the amount of total energy. Alright, and you're saying, well, you should be able to take advantage of that, but the trick is, okay, that if you think about each one of these times you have to try to collect this energy, how are you going to collect it? And no matter which way you think about it, I have to either slow it down while it's falling, like say for example if I was to use a coil of wire or something, there's going to be resistance, to each one of the falls. It's going to fall slower, so it's never going to gain the velocity, so it's never going to have the energy. And if I let it hit something like a scale, you can sort of understand that the termination energy, okay, the fact is it has to hit at the right velocity, so it has to fall the full distance, and then it has to compress the scale. So that's the catch. That's where you're losing all the energy, is because you're lowering the object with the scale to collect the energy. And when you collect it, you've taken a bunch of distance, okay, that it's not going to fall. So it's essentially these stairs, you lose distance with each step. You're losing the amount of distance you have to use to collect it with the spring, which takes a hunk of the stair off, or the distance. So you're not going to be able to drop it the full distance, because 4 times you're going to lose this hunk of distance it took you to collect the energy. And that's the big difference. So when you collect it this one time, the scale drops. You drop the 10 pounds, the scale drops the level of the object, the distance of the spring's compression, okay? And that doesn't matter, because you're not having to do it again and again. It doesn't matter how deep into the earth. If I drop this onto a scale that's flat with the earth and the scale drops down 10 feet, I wouldn't care. It doesn't matter to me. And you could argue the same thing happens when you're launching something, right? You're going to launch it from somewhere lower, right? If I compress a spring and then I launch something, the real launch position isn't where the spring is when it's compressed. The real launch position is when the spring fully expands. So the distance of the spring's expansion has to be understood as part of the distance required to get it to twice the velocity. So that explains why you're losing so much energy. And then you have the friction, of course, of also trying to trap the energy, sliding something over the spring and pulling it back again. There's all kinds of friction. You also have to push the ball so it falls down the stair again. There's more friction. So that's one of the reasons you could argue it doesn't work. Now the trick is, so maybe I'll erase this. The interesting fact is that you can gain more and more energy by going with more and more distance and creating more and more stairs. But the catch to that is, I guess I didn't need to erase that, but whatever. I think you know what the subject is. Hopefully you're following along that far. Alright, so it's the Galileo thing, right? Okay, so in the first unit of time and distance, well, time is really what you're using to measure. Something will fall that far, and then the second unit goes that far, and then the third unit goes this far. So it's 5, 3, 1. And so you could understand that it's only getting 9.8 here, right? And then it's 19.6, and then it's 29.4, and so on and so on, in terms of what you've collected from gravity. So in this you're only getting 9.8 per these bigger and bigger hunks of distance are giving you less and less energy, right? Per mile, per foot, you're getting less and less from the gravity. So that's why it's mgT. All right. So the trick is if I made that staircase using 3 units of time, okay, letting it fall further, then you'd end up with a scenario where it's 3 units of time to fall, and then it's 9 units of time to fall with the staircase or the ramp. If I use the ramp at the right, so I can change the ramp to any pitch. I can have it really just a tiny pitch, and theoretically it could take an hour to roll, versus just falling in very few units of time. But I think you have to keep this ratio. Well, I shouldn't have gone that far. But the point is you can figure out the staircase isn't much different than the ramp, okay, except it just has these little cutouts in it, right? So it's the same principle in a sense, and that's what's defeating you, is that there's just too much friction and there's no way to measure it. There's no way to collect the energy while it's falling on the ramp without taking the energy out of the system. So you can't collect any extra energy because of the fact that it's taking longer to fall. Alright, I think that covers. Let's just see if there's any notes I had on that particular thing. No. But, I can see it's, again, this is one of these things that seems paradoxical, but it seems paradoxical right from the start in the sense that, this 1 to 3 thing, okay, it's just very unintuitive that this is only twice the time, twice the velocity here. This is only twice the velocity, so it went 4 times the distance, but it's only twice the velocity. And then here it's going to go 3 times the distance, and it's going to be only, it's going to go 9 times the distance. Nine of these units of distance, of time. It's going to go 9 of those. It's not 9 times, sorry. It's only 3 time units. It's 9 distance units, and it's only going to gain 3 times the weight. Yeah. And it's only going to go 3 times as fast. It's only going 3 times as fast, but it fell 9 units of distance. All right, so that's on its face troublesome, irritating, but it's not what he claims it to be. And this still explains it better than mgH. Obviously better. Because mgH says, okay, there's 9 times the energy. And it's only 3 times the velocity. And it's only 3 times the weight. So that doesn't work. Alright, so the other thing I thought of, I'm thinking of experiments to do that can, simply provide this decisive evidence. Something as simple as the Mythbusters experiment, something, that's beyond screwing up in some way or another. But they're all catches to them. I mean, if I had a high-speed camera and all that kind of stuff, it would be a lot. This would be more fun, okay? Because these are all experiments they should have done by now. So I was thinking of Newton's cradle, and the catches. You can't do the uneven mass thing, and so I thought of at least you could show what happens when it happens. So this is basically just saying, 10-ton train going 5 miles an hour versus the 5-ton train going 10 miles an hour. Now this is supposed to have twice as much energy by their mgH and their 1/2 mv squared. This has 200 joules of energy, let's say, and this only has 100. Not the accurate number, it's 125 and 250, but whatever. We're just using any switched velocity to mass ratio. Okay, and so so I put the big object here, the small object here. I want this to have twice the velocity, so I'll go 4 times the distance up into the gravity. Okay, 4 times this distance, 2 would be about the same, and 1 unit of distance for this. So we go 4 units of distance here. And the catch is you have to drop this. Okay, this one has to be released. This is going to take twice the time, so that's the catch, right? This will take twice the time as this. So this will only take 1 unit of time. This is going to take 2 units of time. So that's what really screws up the continuity of allowing the Newton's cradle to deal with it, because the energy doesn't meet at the right time. It doesn't. Their maximum velocities don't hit each other reliably. But that's all we're testing in this case. So I move, the objects to the appropriate place, and what you have to do is let this go. When it goes 1 unit of time, that is 1/4 of the distance, then you let this one go, and they'll meet, in this exact middle here. And the question is will the energy transfer directly through these 2 objects? Because theoretically, I would argue, they have exactly the same energy. So frankly, this one should just rebound to the same height, and this one should rebound to the same height. This is essentially the energy from this object going to this object, send it this way. This one will do exactly the opposite. This energy going to this object, and it'll go on its way. And so that would sort of prove the case that if you got that result, that is, if this reflected exactly back, well, it'll be a little short, and this one will be a little short. Okay. But theoretically, that'll happen on the first bounce. Now, the second bounce is going to be a mess because this is twice the distance again. So this is going to come back and forth and start going this way before this one's heading back. And so they're going to meet somewhere where they're not going to, this one's going to have less velocity because it's going against gravity. So this one's going to be less than its, or should be, a velocity. And this one's going to be great. It's not going to have achieved its full velocity either. So they're going to meet in a position where they're not going to have their maximum energies. Alright, so anyway, it is an experiment. It's doable. You know, how good a picture of it I can get, we'll have to wait and see. You know, if I can get around to doing it, or somebody gets around to doing it. But there's lots of little experiments like this that, you know, need to be done. And that would clean up some of this mess. Alright, let's see if there's anything else I need to draw at this moment. Okay, I did the rampy thing. Yeah, that's pretty much it. Alright, now we'll read the comments. The rude and obnoxious crap that comes with the territory, unfortunately. Alright, so I guess I can do that. And then I guess we'll do these crappy comments first, I suppose. Doesn't really matter, they're all crappy. Comment by that Tim guy that was pretty annoying, but it's sort of related to this in the sense that, geez, so many distractions. I mean, people just do not want to stay on the subject. Let's see, come on over here. How can I get that thing? I want to move this back a while. Yeah. Alright. So, mindless marvels. So, this is a quote from, I don't know, it's an endless quote. That doesn't even make sense. As I demonstrated in one of my videos, his notion of energy means you can collect more energy just by changing an object's time falling. So that's the key word there is collect. Alright? So, can you collect it? Is there some method to collect it? Okay? You could argue that Joule dropped things in gravity by slowing them down, right? I mean, he made an object fall slower, okay, and in essence was extracting more energy from the gravitational potential. You could argue that any time you drop a pendulum, you drop any kind of weight slower, you are in fact collecting more energy. And again, the ramp proves it in the sense that obviously you end up with an end velocity of the object, and you end up with all the friction you created, all the heat from that friction. So it's clearly more energy. Now the question is, can you collect it as more energy? Can you make it into a form where you can relaunch an object? And that's the challenge. More energy just by changing an object's falling time. Well, I'm just saying, how have you proven that isn't in fact true? So again, let's just remember, I drew a ramp, okay, and an object rolls down the ramp. It takes longer for it to get from point A to point B, that is, you know, the surface, alright, and what is it doing in that longer amount of time? It's banging on this surface and heating it. So it's clearly creating more energy in the sense that it created heat on this surface and the velocity of the object. So both things were accomplished. So the extra time did produce more heat, more energy, more expression of gravity's potential because you were being affected by gravity for a longer time. Alright. More energy just by changing an object's falling, causing a violation of conservation of energy. So the question is, it's not a violation till you prove you can collect it, I guess, right? So good luck. You cannot store mgT or mv as potential energy. So again, he's saying that springs don't measure energy. Now, what does then? How do you measure energy? So again, I could just go back to the bowling pin argument where, I asked you to explain how bowling balls work, and all they do is lose their energy to the pins, and they lose it in the form of momentum. Is there any other way the ball can lose its energy to the pin? So let's just ignore all the friction and all the other stuff. Let's just say we have a perfectly slick bowling alley, and all you can do is hit pins with the ball. How exactly, okay, can the faster bowling ball give away this extra energy? Explain it to me. Show me the pins leaving the ball with this extra energy. Because you can't. And I already diagrammed how a bowling ball works. But anyway, so you can keep saying this crap, okay, that springs don't store energy. Well, then you have to explain what they do store, because they clearly do work. Every time you use a spring, it does what you expect it to do, which is you press it twice as much, it produces twice as much force or pressure. So, explain. Because it isn't energy. So again, you can keep saying it. So I don't know what this, as you rightly point out, is in here. I don't even understand the whole way this comment is written is incomprehensible. Okay, he continues to reassert his falsehoods even after being demonstrated wrong. I would say that about mindless marbles. And even after I counter-argued his weak replies. So where did you do that? Yeah, that's right, you didn't do that. You didn't bother explaining how my point about mgh failing to get the 2 plus 2 thing right. I can lift two objects, put them on a scale, okay, let them drop 1 unit of distance each. Alright, and that's going to weigh the same as one object dropping 4 units of distance. So why don't you explain how that, okay, isn't a violation? Okay. And even after I counter, because he pretends like I never said anything back. He doesn't care. I mean, I played your video and pointed out how, yeah, this is an interesting fact, this staircase thing. Okay, but clearly what it is twice the time, right? You're going 4 units of time if you use the staircase thing. You're only using 2 units of time if you launch something. So clearly my mgT survives. Your mgh doesn't. Somehow same distance in your theory, okay, but it is a difference in time. Alright. Care about being right or wrong. He just wants to look like he has something to say. Well, whatever. I mean, I'm obviously more invested in this than that. Idiot does not even begin to describe this disgusting person. So that's the end of a quote by somebody. But again, I would say the same about the dishonesty you people are showing. I mean, it's grotesque dishonesty. Clearly, if I drop the thing, if I slow the thing down, I am forcing it to stay in gravity. And I have to use some force to force it to stay into gravity. I can't make it stay in gravity for free. That's the price you're paying. That's where you're losing your energy, is that, well, whatever you're gaining from being in the gravity longer, you're losing to whatever friction you're causing by forcing the object to stay in the gravity. I mean, you can sort of understand if something's falling and I'm going to create some magical force that's going to slow it down so it doesn't fall as fast and it stays in the gravity longer, that counter force has to be accounted for. Where did it come from? It's got to take energy to be able to give energy. The Earth is taking energy from you pushing in for it to push you back with. Alright, so this is again mindless marvels. How does water work in capital letters? Who the fuck would write that? What the hell context could that possibly have? How does water work? Oh, amazing. Just amazing. What could that possibly mean in the context of all these videos? How does water work? Alright, and then he says, what? Oh, that's brilliant. Do you have an email? So even though the email address is in every single description of every single video, you know, they ask anyway. Alright, more lies and deception. Let's see. Oh, this is just a link to the Castro thing. So there's a paper by this somebody called whatever, Dr. something Castro. Still no evidence it's this moron on the internet. I did get an email where they implied that I'm supposed to pay Mr. Castro $2,000. I mean, they can't even, you know, read a simple description, you know, versus, you know, about the contest. I mean, clearly the contest doesn't say I'll pay anybody $2,000, okay? The whole idea is to get more people to make arguments, to get people to discuss this important physics question. And talking to Mr. Castro isn't going to produce any of that, and that's what I'm interested in. I'm quite certain Mr. Castro doesn't have a counter-argument that means anything, that's any better than the Brozosian counter-argument, which is nothing. He'll say something stupid like, momentum isn't energy. You know, then what is it, fuckhead? It's just amazing. Anyway, amazing to me that they could just keep coming back with this moronic mush that somehow energy is some special thing, that somehow we can't measure it, and therefore we have to appreciate how powerful the energy is that's completely unmeasurable. So again, the simple trick is to come up with an experiment that just says right to you, well, you say the 5-ton train going 10 miles an hour has more energy. Well, let's show it doing more work. Let's show it winning a contest with the 10-ton train. Let's show it producing this, revealing this extra energy it has. That's the simple test. Alright, so it's just to find some way to measure the energy. Jesus Christ. It shouldn't be that complicated. Alright, so we'll go to the comments, I guess. Alright, I'll move this here. That's good enough. Probably can almost read those. Alright, I guess we'll refresh it to see if there's anything new. Doubtful, but who knows. Alright, so Alex Kohler said, who cares? The Andromedians know gravity is caused by particle from the sun. Even a 30-kilometer body would have more than we think. Kilometer, I guess. They are from about 500 meter light years in the direction of Andromeda. Whatever this is. Please, spare me. Alright, can someone give me the lowdown? I don't know what that is. On this schizoid. Whatever. Brilliant. So useful. Oh, no, not really. Alright. That alien head icon is superior minds. Yeah, I was going to say that, but, you know, didn't want to make any, you know, didn't want to cast any aspersions. I just wanted to understand how the hell that happened. Just such a weird fluke. Alright, it did go away. But anyway, strange. Alright, so Mike, I asked ChatGPT. Why do this? You know, it's just a pop culture, whatever, puke engine, okay? It just tells you what pop culture says. It's just Wikipedia, you know, rewritten. But anyway, GPT, so time is not a factor of gravity, i.e. while you are in it. And this was its response. Yeah, I don't know if that's the exact quote you asked it, but that doesn't seem like it should be able to get what you're saying. But anyway, let's see. Let's put the read more thing on. So this was all the crap it wrote. And this is just Wikipedia, so I don't know if it's worth even wasting time with it. Time is not a direct factor of gravity, so obviously that's stupid. So he's pointing out that ChatGPT can't even get this right. Now obviously the faster I go in a gravitational field, the less gravity I'll experience and the less I'll be deflected by the gravity. I've pointed that out 5 million times, but whatever. In the sense that gravity does not depend on how long you are in it. Well, obviously exposure to gravity is what causes you to be motivated by the gravity. And the less exposure, the less you're motivated. I mean, that's just too stupid, frankly. Gravity is a fundamental force of nature. So again, this is more like it's like light. It's like all the stuff moving the speed of light is the fundamental force, frankly. But anyway, it doesn't. That exists between any two objects with mass or energy. So why would energy be in here? So that would be kind of silly. What does it have to do with energy? It doesn't have anything to do with energy. Gravity moves you because you have mass. It doesn't move you because you have energy. I mean, energy is not going to help you get moved by gravity. So that's just too silly. Alright, and its strength is determined by the mass of the object and the distance between them, and how long you're in that distance. And as the distance changes, the amount changes, but it's clearly time dependent, monstrously dependent on time. However, as mentioned earlier, so the chatbot actually says that, weird. The effects of gravity can affect the flow of time. So yes, that's has nothing to do with anything going anywhere, any normal speed, right? So of course this only happens if you're going preposterously fast, which can lead to time dilation. I mean going preposterously fast in the sense of having gravity so strong. Okay, you have to have gravity so intense. I don't even know how to describe how intense it is, right? I mean, it'd flatten you into a pancake, kind of, just incredibly strong gravity. This is a phenomenon predicted by Einstein's theory of general relativity, but not in any coherent way, because it doesn't really explain that you're not going to do that interstellar thing. You're not going to move around in this intense gravity as if nothing. You're not in an intense gravity. The fact that it's stretching the waves, it's going to be stretching the fuck out of you too. Which states that time passes differently in regions with different gravitational potentials, and that's so irrelevant from the question, right? Who cares? In other words, time dilation due to gravity is not caused by the amount of time you spend in the gravitational field. Well, of course, the amount of time, right? So it's turned the question into a time dilation question. So it's not even dealing with the energy created by gravitational differentials. It's talking about time dilation. So, well, anyway, enough. Just crap. Your thoughts. Yeah, my thought is, why are you doing this? That's one thought. It clearly hasn't been able to understand the context of the conversation, so you're not going to get anything relevant. And clearly the Wikipedia page is telling it this isn't about time, it's about distance. So it's just going to keep making arguments that don't have anything to do with the subject. So whatever. So we did this a second time. This is the first time, apparently. How true is this statement? How true is this statement take from open source ChatGPT? The effects of gravity depend on the strength of the gravitational field and the distance from the source of the field. Well, I mean, it's obviously dependent. That's what the R squared is basically saying. Yes, the further away you are from a light bulb, the less light you're going to get. It's going to hit you. Not very complicated. That's not the point. The point is if I'm passing a light bulb, does the speed I go to change how much light hits me? And clearly it does. Yes, yeah, obviously. Less photons will hit you if you travel past the light bulb very quickly. Alright, rather than the length of time you are in the gravitational field. However, the effects of gravity on the flow of time can also be important. So again, we know the flow of time crap doesn't happen until you're going like 98% the speed of light or whatever, but whatever. And can depend on the strength of the gravitational field. Well, blah, 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 blah. Just complete crap. Alright, so the Tim Johnson guy, It was really annoying. I mean, he had to bring up, well, did you read my comment? Blah, 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 blah. And this is just garbage. I mean, he doesn't get what's being done here. Okay, the idea is for you to demonstrate with a piece of evidence. I mean, the plea is for somebody to show a piece of evidence defending either mgh or 1/2 mv squared, or even the work equation. Work equals force times distance, when clearly no, it equals force times time. Something that's, rolling in friction, for example, it goes 4 times the distance and yet it only takes twice the amount of time. It's the same, gravitational arguments. So it doesn't work. The work equation gets the wrong answer. And you have to demonstrate a piece of evidence showing it gets a right answer somewhere. All right. You said in March 20, I'm not going to keep telling you that Einstein's relativity theory doesn't have a thing to do with the stuff moving 30 miles an hour. It's true enough. I was the one bringing up relativity, and I'd like to correct a couple of things. Whatever. There is nothing to do with gamma in the argument, and Einstein's relativity is not needed. Fine. The point I made, this isn't going to matter. The point I made had only to do with Galilean relativity. I'm saying relativity doesn't mean anything in this conversation, so you can keep trying to bring it up like it means something. It just doesn't mean anything. We're not disagreeing about the relative speeds or the relative masses. Those aren't the things in disagreement, okay? So there's no point in having an argument about which one's really moving or any other that nonsense. It doesn't have any part to play in this conversation, really. And the reason I brought up the reference frames is to make the side point that KE is an observer dependent. Well, who made up this rule? And it's, again, it can't matter. It's a differential. It doesn't matter. Observer preserver. I mean, there's no way to undo the fact that the two objects have assignable differences in their positions in space. So there's no argument to be had here. This fact that you can sit there and play this observer game, like somehow I can observe the two objects hitting, I can observe the Newton's cradle this way, where I can't see the objects moving. Yeah, I could do that, but it has nothing to do with this conversation, really. Let's find the stupidest position to watch the experiment from. No, that's not the objective. All right, the reason I brought up the reference is to make the side point that K is observer dependent. So that's just bullshit. Okay, the fact is, if there's a 10-ton train, the fact is if two objects are heading for each other, and one of them weighs 5 pounds and one of them weighs 10 pounds, the fact is, if it's the 10-pound one moving towards the 5-pound one, the collision is going to be different than if it's a 5-pound one is moving and the 10-pound one isn't. That's a fact. All right. From the view of accepted science. So again, this word accepted science. So the whole challenge is to your accepted science. The challenge is I don't accept it. I don't accept your assignment of plus and minus, and I don't accept your 1/2 mv squared, and I don't accept the existence of your fake and phony assertions. I don't accept that light is bent twice as much by gravity, okay, because you don't have any experimental evidence. However, relativity isn't needed to make a sensible argument for 1/2 mv squared in space. I think it's always, you need something to make a sensible argument because it doesn't make any fucking sense. All right, it was invented by a religious kook who thought science was too atheist. That's what you have to overcome. He had no evidence. All right, and the only evidence that showed up was in the 1700s, and it was stupid, lame, let's drop round things into clay and claim there's, this extra energy. But in every other circumstance, the extra energy doesn't show up. That's why you can't show me. You can't link me to a single piece of evidence. You can't show me it taking 4 times more fuel to go twice as fast. And that's what you need to show. And you can't. And you keep evading the fact that this most fundamental thing you should be able to show as evidence, you can't show. And that's gigantic. Why can't you show us it taking 4 times more gas to go twice as fast? Why can't you show us a single experiment where it takes 4 times the energy to double the velocity. Just show us that experiment and the conversation's over. Shit. Alright. You are making a claim that 1/2 mv squared is nonsense. Yes, and the claim is based on pretty good reasoning and evidence. It's clear it was invented by a nonsensier, okay? It was promoted by people who didn't, who were tutored in nonsense, okay? And it certainly wasn't something people were convinced with good evidence. They were convinced by a gimmick, okay? But you are viewing this through the lens of your physics views. Yeah, the physics view, which is, I'd like to see evidence before I believe in something, thank you. I don't believe Jesus walked on water. I don't believe he rose the dead. I don't believe any of that crap actually took place until you show me some reason why I should believe it, besides people said so. Until then, yeah, I'm going to remain a non-believer. Okay, that don't agree with the accepted science. So again, the accepted religion. So let's just replace the word science with the word religion, and your comment will make perfect sense. Okay, I'm rejecting your accepted religion, okay, your wacky theories of reality for which you've never produced any credible evidence. I'm asking you to show me your credible evidence, and you won't do it. So who's a belligerent religious kook here? Clearly you are. Okay. You have your own view of gravity. I have a view of gravity that's not, bizarre and strange as yours. Okay, mine makes sense. Gravity produces momentum in objects. That's what gravity does. It pushes mass. All right. Absolute space, etc. Yeah, I think there's space. Okay, I think there's 3 dimensions. Oh, gee, how bizarre am I? Yeah, no, I think that's a pretty good default position to start from. If you were going to prove that 1/2 mv squared is nonsense in itself, again, not my obligation. My obligation is to ask you to prove your Jesus theory. I don't have to prove Jesus doesn't exist. Again, you just, this is just you don't understand how logic and persuasion works. I have no obligation to disprove your unproven theory. All I have to do is challenge your evidence. And it's so easy to challenge. Again, you never repeated the Eddington experiment from space with 400 times better resolution, and you don't need an eclipse, and it only takes 5 minutes, and NASA never did it? Yeah. Oh, okay. No, I think that's preposterously silly as an assertion. That the most famous experiment in physics has never been repeated because we just don't feel like it. Alright, you have to view the physics through the lens of accepted religion. Yes, of course, it's your accepted religion. You believe based on faith. You don't need to see any evidence. That's your problem, frankly. And in my opinion, it's a big problem. You'd have, I can't say you're very intelligent if you don't understand how important evidence is in persuading, say, a jury or something. Should juries convict people because, well, he says he has an evil soul? That's good enough for me. Yeah. If 2 people have different views of major aspects of physics, so let's understand it's a view of what? All we can view is evidence, experiments, circumstances, conditions, things. You have to give me an observable. What observable have you given me? Oh, that's right, absolutely nothing except circular mathematics, where you say, well, 1/2 mv squared equals mgh, which equals 1/2 mv squared, which equals mgh, which equals mg. You don't have anything. Babel. The Holy Ghost gave birth to God, and then God and the Holy Ghost, anyway, you understand. It's Immaculate Conception. Who doesn't understand that? Alright, anyway. Are you surprised that they will not agree whether the formula in physics makes sense? I'm just saying I'm surprised you don't care about evidence, so that surprises me. It surprises me that you fuckheads don't give a fuck whether you have any fucking evidence. That's really fucking surprising. I'm surprised. I'm really surprised. I'm dramatically surprised that all of you fucking dumbasses that can actually type sentences and or seem literate don't give a fuck that there's no evidence. Alright. And if you're not going to agree to put on an accepted physics pair of glasses. Your glasses are crooked, spotted, the wrong color. They're the worst diffraction lens you could put in front of your eyes. If you want to not see the truth, jump into the accepted physics pool of dark matter, neutrinos, positrons, all kinds of wooey bullshit for which you have zero fucking real good evidence. All right, anyway, and go over an example of mv versus 1/2 mv squared in space. So again, you keep bringing. I love for you to do it in a rocket ship. So go ahead, explain how the bullet with the 2,000 joules turns the ship more than the gun's recoil with only 2 joules. Go ahead and explain that's how it really happens. NASA already knows that. Go ahead and explain how 1/2 mv squared was in the computer that landed the lunar module on the moon. Because well, cert, it wasn't. Okay, that's not how they calculated their thrust. Momentum is how they calculated their thrust. So you're not getting this right. You're not even being fair to your own argument. You're pretending that somehow if I do these experiments in space that somehow 1/2 mv squared works. It doesn't work at all. Okay, it makes it very difficult, maybe impossible to convince you that 1/2 can make sense. Yeah, you know what you need? You need evidence, right? So you're just complaining that somehow you can't produce a single piece of fucking evidence because the magical energy doesn't show up. So even though you assert something as simple as it takes 4 times the fuel to go twice as fast, you're saying, I can't possibly find that evidence for you. I can't make evidence. I can't do experiments. No, I've only had 350 years to do the fucking experiment, but I can't do any experiments. I can't show you any of this magical energy at work. I mean, it's just such a lame argument. You can't admit you should be able to provide a shred of evidence before you're saying you're going to convict something. Again, you're in court and you have zero evidence, and you're making a bold assertion. All right. Because any argument from accepted physics that I bring into play, you won't bring any arguments. You'll just say circular things. You'll use the work equation, and you'll use mgh, and you'll use 1/2 mv squared, and you'll just circularly defend nonsense with nonsense with nonsense, instead of actually producing a piece of experimental evidence. You can always say, well, that's hocus pocus. I think it's hocus pocus when you, like Professor Lewin does an experiment, and he goes in with 100 momentums, and the experiment produces 133 going that way and 33 going that way, and then claims that somehow I didn't make free energy. Yeah, you did. Oh, fuck. I mean, this is so dishonest. I mean, can you just deal with those arguments? It makes sense to you that you can create free momentum in a direction, that I can do an experiment, make something have more momentum. Yes, it gets heavier, but it has more momentum. Okay, and it just keeps, I can keep doing the experiment and keep making 33% more momentum. That makes sense to you? So I can put together a clean example in video form that doesn't even need relativity. So he's just going to put a synthetic. He's not going to show any evidence. We can assume absolute space. Fine. I mean, what? I mean, you think this is a real? Oh, gee, I have to really bend my imagination to accept that there's 3 dimensions of space. Gee, I'm not used to that. I don't know how to handle just dealing with 3 dimensions of space. I mean, it's just like, yeah, oh, I'm sorry. Oh, I'm sorry I have to force you to accept 3-dimensional space. Shit. But you have to agree to at least put on your accepted physics. Again, I'm not doing that. Why should I agree to be idiotic? Why should I agree that 2 plus 2 equals 7? I'm not going to do that. All right. To view the argument, including agreeing to use the formula, see again, for elastic collision. So again, another fake formula for which we don't have any evidence it actually works. So go ahead and keep telling me, okay, what the accepted formula says. The formula made out of combining momentum and mv squared. This is the same formula that Professor Lewin has to cheat an experiment to produce results that are consistent with it. It's so wacky. The formula is idiotic. It claims you don't have to conserve momentum because you pretend that, well, if I throw a baseball 133 miles per hour this way, and I throw another baseball 133 miles an hour that way, I only have thrown 100 miles an hour worth of energy, matter. There's only 100 miles per hour of matter in the universe. Bullshit. Because if you are going to undermine the accepted formulas, I've already done the undermining by pointing out you can't get right answers. Okay, your formula doesn't work. It's not mgH. Because guess what? The H doesn't produce the right amount of energy. 4 times the height isn't 4 times the weight. So explain why springs don't collect energy. So that would be one thing would be interesting. If you have some explanation why I should believe springs don't collect energy. That they collect some other thing, whatever that thing is. They obviously produce energy. So, they give things energy. So somehow you're saying springs don't take energy from things, but somehow they can give energy to things? What's your argument? What kind of excuse are you going to use for the simple fact that anything that has energy, I could say that I could create a spring analogy for the reason why everything has a energy in the universe. That's the whole point of elastic, by the way. It's the storage part. And clearly when you release the storage, you have given the object energy. Alright, if you're going to undermine fancy algebra, derivations, etc., well, why would I even waste my time? I'm just arguing. Are you going to go into a courtroom with fancy algebra derivations? No, you have to go in with evidence, and you don't have any. Then there is no point in me making an argument. There's no point in you making an argument that doesn't conclude any physical evidence. If you don't have any physical evidence, you don't have a videotape of your Jesus, you don't have any kind of fingerprints, you don't have any kind of physical evidence, I'm really not interested. That's right. Okay, because your derivations are just like the smoke, the Jesus farts that come out of the Catholicism's vision of holiness, is to smoke up the room. It's just amazing bullshit. All right, so where do we go from here? We could go to the mindless marbles video and see. Okay, quick argument, he called it. Let's see, maybe we'll go back to his channel page, see if there's a new video. It's just amazing, these commercials on crap videos. Okay, he didn't make a new one.
You don't know what you're supposed to do.
Fuck you in the ass till dead. Anyway, let's see, I don't know which newer or what's not, so let's just see if there's anything here. Probably not. Let's see if there's anything in the chat. Nothing in the chat. Alright, so maybe we'll just get the hell out of here. Alright, so this was the pinned comment, I guess. Let's just see if there's anything here that's recent. One day ago. No. Let's see if there's anything in here. 1 day ago. No. 3. I think there was 3 here yesterday too, so nothing new stated. Okay, so we'll leave it at that, and maybe we'll just make it a regular video, frankly. I read some comments. What else do I need to do? Just experiments. So what we're seeking, so if somebody wants something to do, is come up with ways of testing the energy of objects. And I'd sort of argue that the most relevant test just deals with these things that have inverse mass to velocity ratios. So something 5-pound thing going 10 miles an hour versus 10-pound thing going 5 miles an hour. the inverse relationships, because it just shows pretty dramatically this increase in energy thing. It's even better, I guess, if you go 1 to 4 or 1 to 8, you know, in terms of changing those ratios, because the dramatic difference in the amount of energy. The bullet and the gun example. And the test is, we want to see if bullets actually move 2,000 times more atoms in the universe. Do they give 2,000 times the momentum, okay, the movement, to other stuff in the universe? I mean, how else can you measure energy but to measure atoms or subatomic particles moving? I mean, that's the nature of energy, is stuff moving. The test has to have something to do with showing that one thing moves more stuff than the other thing moves, or that it somehow is capable of producing more wattage or more weight or more something. So it's finding a test, okay, where we can extract the energy from objects and compare the energy that they are capable of producing. And you know, it'd be nice if we could, you know, if those experiments were dirt simple. I think they're pretty simple, but, you know, we somehow have to do a tug of war between the 10-ton train and the 5-ton train, or we have to smash them into each other and see whether the 10-ton train or the 5-ton train can push the collision. See, if the 5-ton train has twice as much energy, it should be able to push the collision. It should be able to move the collision over. If you crash cars, you know, that have, one has more momentum, that's what will happen. So if a big truck hits a light car, the big truck has more momentum, so it wins the contest. Now if they have the same momentum, nobody wins the contest. You know, the two cars crash and turn or flip up or do something, but one doesn't win and move the collision in a direction. Those kinds of tests, I mean, it's just necessary that we come up with something so we can do these tests. All right, there's Tim. Thanks for reading the comment. Okay, yeah, no offense. It's just that you're not really getting it. I mean, for 2 years we've been arguing about evidence. So evidence is what everybody wants here. I mean, I could go back to, like, if you do any research, I mean, I have pleaded with you people, look, I did it. It's not that much trouble. Just look up Leibniz and look up, try to find some of the arguments that were made in the controversy over over mv squared, the living force it was called. And you'll find that there was nothing argued. Leibniz didn't show any evidence. He didn't show an experiment. He just used thought experiments, just like mindless marbles, and made the thought experiment, well, what about this staircase thing? You know, that kind of thing, to point out that how could that be only twice the energy, blah, 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 blah. You know, without thinking it through. And then in the 1700s, they did this stupid clay thing, okay, where they drop round objects into clay, and the fact is they will, okay, if you don't let them fall deeply into the clay, you could sort of understand that the round object, okay, has a real bias, because if you just hit this much of the surface, if that's all the round object that goes into the clay is this little piece, well, you can understand that this little piece is mostly surface facing this way. And that if the further along you let it go, the more likely it is you're pushing clay this way instead. This way is easier than this way, because down has to go that way eventually. So you're going both directions. It's more work to go down and sideways than it is to just go down. Well, you really can't see that because of this stupid thing in the way. Well, you know. I don't know why it won't let me grab that, but it won't. Oh, I'm grabbing it in the wrong window. That's why, you moron. Sometimes I am a moron, but anyway. So you can just sort of understand that the shape of the surface is what's dictating how much displacement there is. So obviously the deeper you go into the clay, the easier it is to go into the clay. The hard part is the first initial part, because that's all flat surface. And once you start penetrating the clay, it gets easier and easier because you're doing more of this surface. All right. So that's a simple physics explanation for why that one bizarre experiment. But if you crush the clay in some other way, you smush it or you use a spring, you'll see that no, it only has only has twice the energy. 4 times the height, twice the weight. That's what you'll really find out. If you do the experiment all the other ways you could do it. And it's only when you do it in this one particular way, it fools people. So it's just like, again, rolling the objects in friction. You roll it in friction, and guess what? It's not going half the speed at half the distance. It's going half the speed at 3/4 of the distance. Huge giveaway that the friction isn't even or fair. The friction when you're going slow is very energy extracting, and the friction when you're going fast doesn't harm you much at all. Alright, anyway. I understand a thought experiment in space won't help us as we can't go out into space and do the experiment. I don't think there's anything wrong with doing the thought experiment. Again, the thought experiment of the gun in your space shuttle. I mean, what's wrong with this thought experiment? I fire a gun. I know Newton's law says it's the same thing going this way, the same thing going that way, right? It's supposed to be a law. Well, your theory is that there's 2,000 joules going one way and there's only 2 joules going the other way. So you have to explain why the spaceship doesn't see any of that. If I let the bullet plow into the side of the shuttle, okay, let's just say it can do that, I've collected 2,000 joules of turning power in this direction. You know, I let the gun fly out. 2,000 joules. Alright? And then I do the opposite. I let the bullet fly out and I keep the gun. I only have 2 joules of energy, turning power. You explain. Or vice versa. Like I said, if you think about it as what you gave away. I gave away a bullet with 2,000 joules of energy. Well, where did I get the 2,000 joules of energy from? It must have been from my shuttle, so I gave away 2,000 joules of energy. Therefore, I should dramatically be turning that way. That ain't going to happen. Because it's the same thrust, it's the same momentum. 1,000 atoms going 1 mile an hour is the same thing as 1 atom going 1,000 miles an hour. Same energy. Could you just even argue that one sentence? That it's the same energy. 1,000 atoms going 1 mile an hour is the same energy as 1 atom going 1,000 miles an hour. Could you explain how that's not true? I understand. Okay, we did that. I just want to eliminate friction, gravity, air resistance. Again, and I don't see how that's to any advantage to your argument. I mean, you just have to explain to me the experiment you're going to do that will somehow demonstrate mv squared, because I'm saying every single bit of what NASA has learned is that NASA says we don't bother with, you know, Leibnizian, okay, bullshit. NASA will tell you momentum works. So it's a counter argument to 1/2 mv squared, because it's pretty clearly saying we don't bother. Thrust is momentum. Thrust isn't 1/2 mv squared. Let's see. You don't have to go to space to perform an experiment, right? Okay, you just have to perform experiments honestly, right? Have you managed to find the source for momentum, or how motion is derived internally? What the fuck could that mean? Have you managed to find the source for momentum? I don't know what you're talking about. All the energy in the universe, I've made this argument about 6,000 times, but matter has no energy innately. Matter doesn't have energy. So atoms don't have energy, electrons don't have energy, protons don't have energy. The little bits don't have, little matter bits don't have any energy. And the stuff is called force, is the stuff in the universe, filling the universe. And the little force bits that make up light and gravity and magnetism and gravity twice, they're the things that have energy, and they're always going the speed of light. So they're little tiny grains of sand. They have a quantizable, consistent capacity to move something. It's a quantum of energy. So it perfectly fits with quantum mechanics in the sense that it's all quantizable. It's all Planck You could give it a Planck unit of. So there's units of energy moving in the universe, and they can stick to the matter bits and move the matter bits. And while they're moving the matter bits, they can't go the speed of light anymore. So when they're pushing the big piece of matter, they go much slower than the speed of light, thus creating the differential that creates gravity, frankly. So anyway, force moves, right? Well, whatever, of course. So, you know, I'm just saying it's that simple. I'm just saying that model works, okay? You want me, I can show you a picture of it, frankly. I can do. I mean, it's I keep waiting on the finishing touches being added, but they just haven't been done yet. Where the hell did where'd it go? I don't know. It says it's not connected. Okay, I guess it's just not seeing it. So I have to bring it back here, I guess. That is weird. That shouldn't just make that happen. But anyway, all kinds of little bugs in this software. Here. So, yeah. Let me refresh it. Oh, I have it at very slow speed, so that's not going to work. And I don't think this menu works yet. All right, so I have to put this one on. All right. So let me just refresh it to make sure. So this is what I'm arguing the universe is, and I'm saying it works. Okay. So there's little bits of force. They interact with the matter. The matter is pushed by the force for the period that it sticks, and it's all conserved. The little bits of force are never destroyed. They always have to either be stuck or they're reflecting and back free again. So they're either free or they're stuck to a piece of matter, and they move the matter. And if you just create an inverse relationship between two kinds of force and two kinds of matter, electron, proton, yeah, look what happens. Boom, bingo, bingo, bingo. You start creating dipoles. Dipole, 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 dipole. And then it's just a matter of regulating how much pressure there is between these objects, and it'll start creating bigger poles. Oh, there we go, 4. See, it'll just keep happening, okay? So this simple mechanism will show you the creation of these relationships between electrons and protons, essentially creating magnetism by creating dipoles. You know. So, but, you know, yes, it can be really simple. You're saying it has to be complicated. I'm saying, no, it doesn't have to be complicated. It can be really simple. That's what I'm saying. Oh, there's the chat. Sorry, I didn't have the chat on the screen. Force moves right. Yes. Where is the source for that movement if it is only singularity? So again, I'm not going to argue somebody else's theory. So if that's all you got to do is to bring up, you know, hyperboloids or something, I'm not going to argue Ken Wheeler's nonsense. I'm not going to argue singularities. It's, in my opinion, just a big pile of crap. There's no such thing as an infinitely small particle or point source or any of that crap. You want to believe it, that's your business, but go talk it to somebody who could care, because I'm not interested. This is like talking about the scales on gremlins. I have no interest in speculating on whether the scales are blue or green. Again, you bring up so-called big bangs. I'm talking about kinetic energy versus momentum. Can you sort of understand what the subject of this channel basically is these basic force relationships that exist? What's the nature, okay, of the function of gravity or magnetism or electricity? It doesn't have anything to do with big bangs or singularities. How would you derive the initial motion of this source? Okay, you're just asking me. Block me, please. Please block me. You have to answer this question to go forward. All of science has to, even me. Oh, fuck you, that anybody has to answer who invented the universe. Nobody has to answer that question to talk science, you retard. Ugh, fuck you. Time him out. I'll time him out. I mean, just what a waste of time. Well, neutrons, I mean, most of physics now admits, and they say it all the time now, right? that neutrons are made, they decay into an electron and a proton. They say an anti-neutrino, right? An anti-neutrino, which is just hilarious. It's not even a regular neutrino. No, it's an anti-neutrino. Obviously, the argument is the neutron is what I just showed you. It's the dipole. When the electron and proton stick to each other, that's a neutron. And obviously, you could sort of understand that if you could turn a neutron or spin a neutron, say if it was a dipole, you wouldn't be able to see it's a dipole, right? Because if it was, it depends on the angle you're looking at. So I could also say it can look like anything, right? It's sort of like a perfect tranny, right? One side looks like a girl, one side looks like a boy. It's perfect. So yeah, you won't recognize it as a dipole. But obviously it was looking at you, with the two poles showing, then it's going to look purple, right? Say if one pole was red and one pole was blue, you'd say, it's purple. It's a neutron. Well, it's not really a neutron, it's an electron and a proton. I mean, that one's pretty simple. People should be able to catch on, okay, that a neutron is the first dipole. It's not neutral. It has both poles, okay? So it's not neutral. It's neutral in the sense that it has both. It's not an electron and it's not a proton. It's a neutron, but it is a dipole. It's not a monopole. It's not an unpole. All right. Do electrons and protons have an attraction to each other? Well, I mean, you're just being insulting now. You think I don't know what charge is? I just showed in the simulation. Didn't I just show it? I mean, what do I have to do? I mean, can somebody please obligate people to be reasonable? Right? I mean, I just showed this, right? Now, the argument is this is an illustration of what's happening in the universe, and these are protons and electrons, okay? So the blue things are protons, the red things are the red things are protons, the blue things are electrons. Either way, it doesn't really matter. I mean, obviously they're attracting, and obviously the blue is repelling the blue, and the red is repelling the red. And I'm doing it with just two simple interactions. It either sticks or it reflects. So with two simple interactions, I'm creating dipoles. I'm making neutrons. You can see this, right? Yeah, okay. Yeah, I'll leave that up. What the hell? I mean, it's not, like I said, there's a couple of the subtle interactions aren't finished yet, but it's getting closer. It's just, the guy only has so much time to work on it, blah, 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 blah. But it's so close. It's really irritating because, it's so close to being up to the first stage, right? And then the first stage, I'm going to have to zoom out, and then we're going to have to deal with atoms and nucleuses and all that kind of crap. But, it's showing the dynamics anyway, that the simple rules create the function. I have created charge, okay, with two simple rules. All right, where is this other stupid thing? That's not it. I want this one. No, I don't want that one. I want this one. Okay. Oh, okay. Same question still. All right. I mean, I'm just saying, look, it's a little patronizing. I've been doing this for a long time. I know what charge is. I accept the existence that there's a thing called charge in the universe. It has to be explained. Magnetism has to be explained. My argument is magnets aren't energy sources. Magnetism is just a reflection. It's energy reflecting off of the magnet. And so the magnet changes what the reflection looks like, and other dipoles can see the change in the reflection. Okay, the model is pretty easy to understand. Okay, yes it is. Let's see, are those tiny forces also the forces of gravity? Yes, that's the, and the key thing is if you understand it, say if I do move something by hitting it with something smaller, a little force sticks, and the little force pushes it. you can understand that while it's pushing it, the little force has less energy because it's not going as fast anymore, right? It's not going to get where it was going. So if you're driving home from work and I don't know, you hit an elephant and you have to push the elephant for a half mile, you're not going to get home at the same time. So in a sense, you've lost energy because you had to push the elephant. So every time matter moves, energy is being taken out of the external field. The external field has less energy because a little force bit isn't getting home. You know, it's not where it should be. It would be further along in the universe. It would be doing more work in the universe if it wasn't pushing the stupid clump of matter. So you can understand why any body would get hot, okay, in gravity, because, you know, the pressure of all the matter pushing, you know, against the matter, and all of that movement, all of that crap moving, the matter moving, means that it's absorbing energy while it's moving. While it's moving, it's elephants being pushed around, and when you push an elephant this way and you push an elephant that way and you push the elephant this way and you're not gaining anything, you're not going anywhere. And so it's all lost energy in a sense to the real universe, and that's why there's gravity. Gravity is the byproduct of pushing matter. So, you know, and so the Earth is pushing matter in contrary directions, which is the same thing as going back and forth, and by doing that, it's creating a reflection coming off of the Earth that's less energy than what went in. More energy is going in than's coming out, because there's a ton of little pieces of matter slowing the force down, so to speak, using the force's energy. So yes, this is all there is. There's just little red bits and little blue bits, and then there's big red bits and big blue red bits. That's all there is. There's just two kinds of matter, two kinds of force, and two kinds of interaction, reflection and absorption. And that's all this model will ever have in it, and that explains all of this phenomenon. So I'm just saying, yes, you can make gravity out of this simple model. Anytime a piece of matter moves, you've created gravity. All right. I know several physicists have a similar model. Oh, fuck you. I'm sorry, but I'm sure there's nothing similar. All right. But go ahead and say that. All right, to yours. You didn't even know that I understand that electrons are attracted to protons. So you say you understand my model immediately and you recognize it as somebody else's. I mean, that's pretty irritating, frankly, when you didn't even know I knew what electrons and protons were a minute ago. Okay, I know several physicists that have a similar model of gravity to yours. That's just a fucking, go ahead, please link me to any indication of this, please. I desperately would like to see a physicist with a rational model of reality. There aren't any. Okay, is there anyone you think is the most similar to your model of gravity? Amazing. Well, where do you have any example of anyone who has a model that isn't full of ether and waves and magical forces? The standard model has, whatever it is, 863 fields. There are 863 momentum fields in the fucking universe according to the standard model. Because there's one for every particle plus the anti-particles. So you have 400 particles plus the 400 anti-particles, and so now you have 800 different fields. Where is that in my model exactly? Oh, that's right. It's not there at all. I mean, you really are, you really are just so fucking irritating. I mean, please, again, show me a link. Show me anything that looks anything like this model. Something as simple as 4 fucking, 6, 2 plus 2 plus 2, 6 elements. Show me the 6 element model of the universe. Oh, shit. The guy evades reasonable questions about the basics. I'm not too interested in the rest. This guy evades, I don't know what that means. Evades reasonable questions about the basics. I'm not too interested in the rest. Well, whatever that means. They are called the push gravity models. these are old physics. Tom Van Flanderen. Okay, well, whatever that is. Okay. Yeah, well, yeah, Lesage gravity didn't work because it has the drag problem, blah, 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 because it wasn't quantized. A lot of things are wrong with it. All right. So, yeah, you could say this is a variation on that theme, but you said, I know physicists. I know several physicists. Okay, well, introduce me. Okay, because I can't find any. There's no living rational physicist. Are you kidding me? Where are they? I mean, I'm sorry. It just seems almost ludicrous to me because I haven't seen a glimmer of reasonableness in physicists. Or engineers, or anyone. I can't find people who are reasonable. All I find is wooicles. I mean, everybody just wants to make it wooier and wooier. There's plenty of Ken Wheelers, You will gain 4 twice the momentum. What is that? Okay, you will gain 4 twice. I mean, damn. The momentum when the masses drop 4 times versus 1 times from 4 times the height. All right, James, I don't know. There's a point where, fuck you. What the hell is this? You will gain 4 twice the momentum when the mass is dropped 4 times versus 1 times from the same height. Okay, well, why don't you show it 4 twice the momentum? You have to pick one of those. The point is that all you'll get is twice the momentum. 4 times the height, twice the weight. Weight is momentum. Mass times velocity. That's what weight is. Weight is your mass times whatever movement you have. Shit. Tim Johnson. I agree with him on one thing. You have to figure it out on your own. Oh, my God. Whatever that even means. You can't rely on other models too much. You have to rely on evidence. And then you have to use reasoning and logic. And certainly other people can save you an awful lot of time by explaining something. See, I could do that staircase thing, right? Mindless Marbles thinks about the staircase thing, but you might not realize, oh, wait a minute, that does take 4 times the time. Dropping an object down the staircase will take 4 units of time. So it'll take twice as long as just letting it fall. So the two things are distinctly different. One of them takes twice as long. At minimum. It'll take much longer than that, but you have to move it sideways and drop it again. So if you could drop it and then instantaneously drop it again, and then instantaneously drop it again, it would take twice as long. Obviously, if you actually rolled it down a staircase, it would take even longer. All right, do the calculation, you will see. All right, that is so vague and useless. Do what calculation, you fucktard? Drop something on a scale, fuckhead. Do an experiment for me, James, okay? Drop something from 4 times the height onto the scale. Drop it from 1 inch and then drop it from 4 inches and show me it weighing 4 times as much, fuckhead. Because it doesn't. So until you can show something, your comments are fucking just more jabber. I mean, man the fuck up. You have an obligation, especially since you can't do anything but type. You have an obligation to show something. You have to link to something. You have to in some way prove your point. You can't just make your assertion. Alright. I just meant I know of them. Oh, well, whatever. In some vague way. Okay, got it. Yes, I agree with you. I don't know of any push gravity type physicists that are living. There, okay, fine. You will gain twice the momentum when the mass is dropped 4 times. Yes, twice the momentum is twice the speed, you fuckhead. That's exactly what I said. So what are you fucking talking about? Alright. When a mass is dropped 4 times versus 1 times from 4 times the height. I mean, you have to learn how to type. These sentences are insanely convoluted. You will gain twice the momentum. Well, that's the truth. When the mass is dropped 4 times. Yes, you should have just stopped there. Yes. And that's not something I'm contending, you asshole. That's something I've only made hundreds of videos saying, asshole. Versus 1 times from 4 times the height. What the fuck could that piece of shit on the end of that sentence mean? Versus 1 times from 4 times the height. What the fuck is that? Never mind. Just go ahead. Go ahead. You know, trigger my reaction. Because you're right on the verge, fucker. Alright, at Tim Johnson. And that means we have to move beyond Isaac Newton. So again, what is that? What does that even mean? You're better, you're smarter than Newton. Newton didn't make any mistakes. He predicted things correctly. Beyond it to what? You know, the magical wavicle. I think there's evidence for the momentum or even more basic speed. So you can't talk anything but baby talk too, right? What the fuck could that mean? I think there's evidence for the momentum or even more basic speed. What the fuck could that mean to somebody with a brain? Oh shit. The explanations or symbols used to represent it means nothing to me. Well, obviously logic and reasoning mean nothing to you. I personally want to know exactly where or how these basics derive. Yes, you want to talk to God. Well, guess what? You're not going to do that, fucknut, and you're certainly not going to do it on this channel. I think it's just time to say goodbye. I'll see you. Hopefully never. Oh, god damn, this planet is just, there's way too many fucking loonies walking around free. Alright, sorry for the question. As I'm just learning about push gravity models, can you share what Lesage drag problem is and how you solve it? Well, the solution's complicated. You can look up Deuteron, I suppose, but the drag problem is if I create a particle model and it's completely conservative. Well, the idea is while I'm pushing the electron, the idea would be as I'm pushing it into more energy, right? So if I'm going this way and I have an even field of energy, you know, energy going this way and this way, a same amount. As I move in a direction, I'm going to encounter more opposing energy. So more energy, the faster I go, the more I'm moving into a field of energy. And therefore, I'm going to get more resistance to my motion, and therefore my motion's going to be absorbed. But the trick is it really doesn't matter because over a time interval there's only so much energy in the block of time. So you could argue that one way of defeating the drag argument is using your space, big space kind of analogy, is that there's only so much energy in the universe, and the stuff going behind you that you're racing away from, right? The stuff not pushing you will eventually show up, right? So if you slow down, the stuff you're speeding away from will catch up with you and hit you. So in a sense you can argue that it ends up just being circular, that there is no technically real drag, because over a certain distance it was inevitable how much stuff was going to hit you anyway. Just because you're in between these two, you're in between 2 points in space. Those 2 points in space are going to get hit by a certain amount of energy no matter what happens. No matter where they are in the space, they're going to get hit by that total amount of energy that's going to go through that space. So you really can't change how much resistance there is to motion except in very short intervals of time. Over long periods of time, it's all going to be the same. But that's the essence of the drag argument, is the faster you go into the wind, so to speak, the more the wind is pushing you backwards. Alright, I mean, why bother talking on text and trying to disprove the argument if you can't simply prove your point with an experiment? I'm just saying the focus of the argument, the reason why there aren't experiments is because, yes, they have to be done well and they can't be gimmicky like the clay experiments. So it's not, you know, it should be agreed by all that of the trillions and trillions of dollars spent by science, they should have spent some time doing these basic elemental experiments. And the fact that they spent no time on it is disgraceful. So I don't think you have to say it that harshly, but yes, clearly the focus should be, can we find experimental evidence? Because there is no point in just making assertions that you can't defend with evidence. But I could say things like, well, whatever goes up comes down, and I shouldn't really have to prove it, you know what I mean? So there are some things you can say that should be, that we don't have to have an experiment for. But yeah, no, it's always, yes, it's good that you're pointing out experiments. I'm just saying the conversation should be about finding them and finding credible ones. I guess I'm just trying to get to the point that there's some arguments you're never going to have an experiment to show. I mean, that you're just going to have to model the system. You can't show the experiment because the experiment is inaccessible. So you have to just model a mechanism that produces the result and say this model works and some other model doesn't work. So I'm not against modeling, I suppose is what I'm trying to say. But yes, experiments. We need experiments. Desperately. We need some good experiments. We need to see the 5-ton train going 10 miles an hour doing more work. We need to see it do more work than the 10-ton train going 5 miles an hour. We need to see the 16-pound ball going 8 miles an hour knocking down less pins than the 8-pound ball going 16 miles an hour. We need to see that. Divide it by 4. Oh, well, whatever. What the fuck are you talking about, you nut? It's just, sorry. It doesn't make any sense. So again, like I said, until you show me the experiment where 4 times the height equals 4 times the weight, you're out of luck, James. Or where, show me that twice the velocity isn't all that's required to go 4 times higher into gravity. All I need is twice the velocity. Show me the experiment where a spring, I compress a spring and launch an object. And then I take 2 springs and launch the same object. Your argument is it doesn't go twice as fast? You have to show me that. Alright, a little lull in the action. Maybe it's time to go. Let's see, I'll give it a couple more minutes. New to the channel. Is light the tiny force bits in the model? Yeah, it's in the background, right? In the video right now, right? Yeah, it's in the background of the video right now. Yes. The little crap moving around is the force. It's going the speed of light. Obviously, I'm modeling it much slower than its actual speed. And the little red and blue things are protons and electrons. And as you can see, they're turning into dipoles. Oh, Tim, again, new to the channel. What? You've already been here a while. Is light the tiny force bits in the model? Yes, the force bits at a frequency is light. Obviously, it's the electron force, because the electrons get moved. Okay, so you could argue that the only force that's relevant is the electron force, because the electrons are the only thing movable. The protons are heavier, so they don't move as easily, and they're harder to get to because they're stuck in nucleuses. Okay, well, try not to get killed and such. Yeah. Try to evade the horrors of the real world. I do empathize. Yuck. Take the total velocity, plug it into the kinetic energy formula, and record the value. Take the total velocity, plug it into the kinetic energy formula. What does that even mean? I already just did that. I just showed how it doesn't work. The kinetic energy formula says 2 equals 4. Then take the velocity from 1/4 the height. Again, I'm not playing. Whatever game you're playing, I'm not playing it anymore. Plug that into the kinetic energy formula and record the value. So again, this is just gibberish. You'll get the wrong answer, asshole. mgH doesn't work. And mgH is 1/2 mv squared. The two have the same opinion in gravity. Yeah, I'm hoping to drive safely to work. People suck. Yes, it's so bad. I don't even know what to say. Anytime somebody I know goes driving somewhere, all I do is fret. It's just, oh shit. Hope nothing stupid happens. See, different people have different views on the question. Well, doesn't everybody already know that? I mean, the point is whether the views are reasonable or not. Is it reasonable to believe light is bent twice as much by gravity when you really haven't been produced any evidence that it's bent twice as much? Is that reasonable? Is it reasonable to believe shit you haven't seen them show you? Okay, again, you're believing it takes 4 times more fuel to go twice as fast. Do you have any evidence or reason to believe that? I think you would have an interesting answer if it's okay for me to ask. I don't even know what that means. Go ahead and ask. I'm just saying there's some questions I'm really not going to... I just couldn't care less. I don't care, how big the Andromeda Galaxy's wiener is. I mean, if you're going to ask some stupid fucking question, I'm really not interested. The kinetic energy from 4 times the height will be 4 times the energy. So again, you just keep saying it, okay? You have no experimental evidence demonstrating it, James. So I'm just going to put you in a timeout. I mean, you just keep saying the same shit. You have no evidence. Fuck you, all right? You're making assertions that I claim are absolutely wrong. It isn't true, okay? So until you show it to be true, I'm saying no, it isn't. I don't know what else to say to you, okay? It ain't going to work, conversation between us. Your assertions mean absolutely nothing to me, okay? Your math doesn't get the right answer. 4 times the height is not 4 times the energy. It's not 4 times the weight. It's not 4 times the velocity. It's not 4 times the time. It's not any of those things. So fuck you. What is time? Time is just the fact that the universe isn't instantaneous, right? If the fundamental thing, okay, happened instantaneously, then there wouldn't be any time because everything would happen all at once. But obviously things are slower than instantaneous. So that's it. That's all there is. Things move a distance and it takes time to move the distance. Period. So we're done. So you could say time is just a byproduct that the energy in the universe is limited in its speed. It's going the speed of light. So that limitation dictates all other slowness. I mean, obviously you're running so incredibly slow, right? I mean, your brain is like, whoa, I mean, you're just so slow compared to, okay, the mechanisms that are making your consciousness, right? The speed of light, electricity shooting around, blah, 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 all the crap buzzing through you, and you're this incredibly slow motion that comes out of that as a byproduct. So, but yes, the time is just a byproduct. It's just an emergent consequence of it taking time for a photon to go from point A in space to point B in space. It takes time, therefore the universe has time in it. But I would make the argument to you, like, if you believe in this relativity crap, the relativity crap just means that, you know, the argument is if you start moving something faster and faster, you're essentially just making it go slower and slower. It functions slower and slower. The heart beats slower and slower. Everything just slows down. So you're just freezing somebody. So if I was to send somebody into the future by giving them preposterous speed, all I'd really be doing is freezing them, you know, and then de-thawing them when they landed. I mean, there's no... the fact is they're not going to live longer. They're not going to live more. They're not going to have more love affairs or more interactions or more life. They're going to live the same amount of life. They're just going to do it incredibly slowly. All right, good for you, I suppose. Go ahead, head out. I got to head out too. So yes, we all have to be doing our heading out thing. So yes, so a couple more minutes and I'll also head out. Yeah, I know. It's just really, I watch these people. I mean, and there's just these morons. They should just, I don't know why the cops, I wish they would quit beating up innocent people and just shoot all these assholes. I mean, you watch people going down these residential streets at 70 miles an hour in cars with no muffler. And you're just saying, why hasn't somebody shot this fucker? I mean, what's the big deal? Who's going to miss him? I mean, they're so obnoxious and so fucking, they're such preposterous assholes. You're just like, no. I mean, this is too silly. I mean, the guy next door has a motorcycle. It's you can hear it. You can just listen to it as it goes a mile away, and then it's a mile and a half away, and you can still hear it. I mean, what kind of obnoxious fucktard does that? So yeah, it's really scary. Well, just people are scary, frankly. I'm just saying, it's just the average person is just, you know, their conversation is inane. They're, you know, I mean, there's just nothing functioning. They're so dead. I mean, it's just the zombiness of being really stupid. Ugh. I think you said in a previous live stream that you garden. Is it vegetables? Yeah, it's both flowers and vegetables. It's just beets and tomatoes, really. Beets, tomatoes, and broccolini. Because that all works out well for me. Keeps me fed all, you know. My beets lasted until like the end of January, middle of January. So I really, you know, it's like for 10 months out of the year I have all the vegetable I need. 9 months. But the flowers, you know, the flowers, it's about the flowers. Yeah, quite an impressive flower garden. I'm doing dahlias now. I'm finding them kind of interesting as a flower. So I have a lot of dahlias this year. Yeah, I mean, you know, when you eat tomatoes every day, though, they do get a little, after, you know, I'm just saying, I do eat the same thing every day, you know, beets and tomatoes, and beets, you know, and rice, and it does get a little bit, yuck. Yeah, I like the smell of mint, but I don't see any use for it otherwise. It's pretty, it grows easy, and it smells nice, but it doesn't do much else. Yeah, I have giant hibiscus, but that's the problem with hibiscus is they're so fucking big, and they do tend to take over. So it's you have to try to figure out how to keep things under control. I did find that you can cut them. You cut them back when they're growing, and then they won't grow quite as tall, but they'll still have the same flowers. So that works a little better. But yeah. Yeah, well, I have one of the temperature-sensitive ones, so I had, I'm trying to get it, well, we'll see if I successfully put it into dormancy and see if it successfully survives the dormancy. So it's the first time I've tried that. But I have the kind that can survive the winter, which is, mostly. Yeah, the first thing I'm going to have is the forget-me-nots are almost blooming. So I have forget-me-nots everywhere. So the whole yard is going to turn blue. Yeah. So it's always a nice start. And then all the other stuff starts flowering and do. But yeah, it is kind of a silly indulgence. Anyway, enough of that trivial, frivolous, sissy mush. Yeah, so till the next time, and such, and so forth and whatnot. Appreciate the conversation, even though it does get a bit difficult. I've just been here and done this, so I'm sorry I'm so impatient, but it's been a long, horrible ordeal. And it just gets so tiresome having to make these points over and over and get no reasonable response, no reasonable concession. People should at least be able to say, oh, physics should have tied this stuff up better than this. I mean, they shouldn't be asserting things as truth without, making the evidence to present. I mean, they're coming to court with such, an undeveloped case. They're making such silly arguments, frankly, in court. Oh, well, we would have had evidence, but it's a little bit extra work, and I couldn't get anybody to stay overtime, and whatever. They're just dog ate my homework. I mean, it's just such lame excuses for why they haven't created the evidence and then present the evidence in like an evidence museum. Just so everybody can go look and see why they believe in dark matter, or why they believe in quarks, or why they believe, and it should be evidenced. Why do you believe light is bent twice as much by gravity? Well, what's the great experiment that demonstrates that? All right, anyway. Okay, so until the next time, and such and so forth and whatnot.